The morning of March 18th, 1943, at the Wehrmacht testing facility near Kummersdorf, south of Berlin, Major Heinrich Vogel stood in the cold observation bunker, watching as his ordnance team prepared to fire a captured American heavy machine gun at a series of steel plates. The weapon before them, a Browning M250 caliber machine gun, had been recovered from a downed American bomber near the Dutch coast 3 weeks earlier. The crew hadn't survived, but their aircraft's defensive armament had remained remarkably intact. Vogel had examined thousands of weapons during his 12 years as a ballistics engineer for the Wehrmacht's weapons testing division. He'd evaluated everything from French anti-tank rifles to Soviet heavy machine guns captured at Stalingrad. But this American weapon represented something different, something that intelligence reports had been describing with increasing concern since American bombers began appearing over European airspace in growing numbers. The intelligence briefings had been clear enough. American heavy bombers bristled with these 50 caliber weapons. B-17 seconds carried up to 13 of them. B-24 seconds mounted 10. Each bomber that crossed into German airspace brought dozens of these guns, creating defensive firepower that was claiming alarming numbers of Luftwaffe fighters. German pilots reported that American defensive fire was far more lethal than British formations using smaller caliber weapons. But the reports seemed exaggerated. Pilots always exaggerated enemy capabilities. It was human nature to attribute losses to superior enemy technology rather than admit tactical failures or simple bad luck. Vogel had spent his career separating propaganda from reality, distinguishing genuine threats from imagined ones. His job was to provide objective analysis based on measurable performance, not pilot testimony or intelligent speculation. The German understanding of heavy machine gun capabilities was shaped by their own weapons. The Luftwaffe used the 13mm MG-131, which fired a relatively heavy projectile at modest velocity. It was effective against aircraft, adequate for its intended role. The Wehrmacht employed the 15mm MG 151 inches anti-aircraft rolls, which delivered respectable performance within expected parameters. Neither weapon was designed for armor penetration. Both were intended primarily for anti-aircraft work or suppressing infantry. The concept of a heavy machine gun that could effectively engage armored targets seemed impractical. Such weapons would be too heavy, consume ammunition too quickly, and lack the precision necessary for anti-armor work. That's what German doctrine taught. That's what German engineers believed. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But the American 50 caliber ammunition laid out on the testing bench told a different story. Vogel picked up one of the cartridges, feeling its substantial weight. The round was enormous compared to German aircraft guns, 53mm long with a projectile diameter of 12.7mm. The cartridge case itself was 99mm long, containing a powder charge that dwarfed anything in comparable German weapons. What struck Vogel immediately was the variety of ammunition types. The American crews hadn't just loaded their guns with standard ball ammunition. The belts contained multiple projectile types, color-coded for easy identification. Silver-tipped rounds marked armor-piercing incendiary. Black tips indicated armor-piercing. Red tips designated tracer rounds. The Americans had created an entire ammunition system, not just a single cartridge type. German weapons testing doctrine emphasized systematic evaluation. Before firing tests began, Vogel's team conducted detailed physical measurements. Each projectile type was weighed, measured, and sectioned to reveal internal construction. The results would establish baseline data against which performance could be assessed. The armor-piercing incendiary round, the silver-tipped cartridge that would become the focus of intensive testing, revealed sophisticated engineering when sectioned. The projectile core contained hardened steel, heat-treated to penetrate armor plate. Behind this penetrator sat an incendiary compound designed to ignite upon impact, setting fire to fuel or ammunition on the far side of penetrated armor. The entire assembly was jacketed in gilding metal to prevent barrel wear. Sergeant Otto Becker, the team's master gunsmith who had maintained weapons since the Great War, examined the Browning mechanism with professional appreciation. "This is not a complicated weapon," he observed, working the charging handle and inspecting the bolt assembly. "Americans have made it simple to produce, simple to maintain, but the tolerances are good, better than I expected from mass production." The Browning used a short recoil system with a vertically sliding breech block. Unlike German weapons that often employed complex roller-locked or gas-operated systems, the American design was mechanically straightforward. It could be field-stripped with minimal tools. Parts appeared interchangeable, suggesting manufacturing standardization that German weapons often lacked, but mechanical elegance meant nothing without performance. The real test would come when they actually fired the weapon against realistic targets. Vogel had ordered a series of steel plates manufactured to match armor thicknesses found on German vehicles. The test series would begin with 8mm plates, representing typical aircraft aluminum armor, then progress through 15mm, 20mm, and finally 25mm plates matching light armored vehicle protection. The testing protocol called for firing from multiple ranges. They would start at 100 meters to establish maximum penetration capability, then extend to 300 meters, 600 meters, and finally 1,000 meters if the ammunition proved capable at shorter ranges. Each plate would receive 5 rounds, with penetration depth and damage characteristics carefully documented. Vogel expected the American ammunition might perform adequately at close range. Most weapons could penetrate thin armor when fired from near point-blank distances. The real question was effective range. Could this heavy machine gun ammunition penetrate meaningful armor thicknesses at combat distances where fighters actually engaged bombers? That's what Vogel needed to determine. The first test target was positioned at 100 meters. The 8mm plate represented the aluminum armor found on many German fighter aircraft, protecting critical components like engines and cockpits. This thickness was chosen deliberately, as it matched the protection German pilots relied upon when pressing attacks against enemy bombers. Becker loaded a belt of armor-piercing incendiary rounds, chambered the first cartridge, and settled behind the gun. Vogel gave the signal. The Browning roared to life with a distinctive heavy mechanical rhythm, completely different from the higher-pitched chatter of German weapons. The deep pounding cadence spoke of massive projectile masses being propelled at high velocity. 5 rounds downrange, the firing stopped. The observation team approached the target plate through the cold March morning air, their breath visible in the chill. What they found would be the first in a series of discoveries that would fundamentally challenge German understanding of American military technology. The 8mm plate hadn't just been penetrated, it had been destroyed. All 5 rounds had punched clean holes through the steel, with entry holes approximately 13mm in diameter and exit holes nearly twice that size. The projectiles hadn't simply pierced the plate, they had carried through with enough residual energy to continue traveling hundreds of meters beyond. More concerning was the damage pattern around each penetration. The steel showed significant deformation, with star pattern cracking radiating outward from impact points. This indicated that projectile impact energy exceeded the steel's ability to absorb shock without structural failure. On an actual aircraft, such damage would compromise structural integrity far beyond the immediate impact area. Vogel made careful notes, maintaining professional detachment despite growing unease. 8mm penetration at 100 meters was impressive, but not unprecedented. The real test would come with thicker plates at longer ranges. The next target, 15mm plate representing heavier aircraft armor or light vehicle protection, was positioned at the same 100-meter distance. Again, 5 rounds fired. Again, clean penetrations. Every projectile passed completely through 15mm steel, leaving gaping exit holes and severe structural damage. The incendiary compound had functioned as designed, with scorch marks around entry holes indicating that the projectiles had been carrying fire through the armor plate. The observation team worked in growing silence. This wasn't supposed to happen. 15 millimeters of steel should have stopped or at least significantly slowed heavy machine gun projectiles. German 13 millimeter aircraft guns certainly couldn't achieve this level of penetration. Yet, here was clear evidence that American 50 caliber ammunition was performing far beyond comparable German weapons. The 20 millimeter plate represented a critical threshold. This thickness protected German half-tracks, armored cars, and the side armor of some light tanks. If American heavy machine gun ammunition could penetrate 20 millimeters at combat ranges, it meant that aircraft could potentially engage ground targets that should have been safe from anything except dedicated anti-tank weapons. 5 more rounds fired at 100 meters, 4 complete penetrations. The 5th round stuck halfway through the plate, its penetrator lodged in steel that had finally proven thick enough to arrest the projectile. But 4 out of 5 penetrations through 20 millimeters of steel from a heavy machine gun was extraordinary performance. Vogel felt the first stirrings of genuine concern. This wasn't incremental improvement over German weapons. This was categorical superiority in a weapon system Germany had considered relatively unimportant. The implications were staggering. If American bombers carried dozens of guns capable of this penetration, they represented anti-armor threats far beyond what Luftwaffe doctrine had anticipated. The 25 millimeter plate would be decisive. This thickness represented the frontal armor of German half-tracks and the side armor of Cottis, Panzer III and IV tanks. No one expected heavy machine gun ammunition to penetrate such protection. Anti-tank rifles struggled with 25 millimeters at close range. The idea that aircraft defensive guns could threaten armored vehicles was simply not part of German tactical thinking. The target was positioned at 300 meters, a more realistic combat engagement range. If the American ammunition could penetrate 25 millimeters at this distance, it would represent performance exceeding most anti-tank rifles. Vogel doubted it was possible. The projectile would have lost significant velocity, traveling 300 meters. The steel was thick enough that even with retained velocity, penetration seemed unlikely. Becker loaded fresh ammunition, adjusted his aim point for the increased range, and fired 5 deliberate shots. The team approached the target with professional curiosity, mixed with a growing sense that their understanding of American weapons technology needed fundamental revision. 3 rounds had penetrated completely through 25 millimeters of steel at 300 meters. 2 others had penetrated more than 20 millimeters deep before stopping. The evidence was undeniable. American 50 caliber armor-piercing incendiary ammunition could defeat armor thicknesses that German doctrine considered proof against anything except dedicated anti-tank weapons. Vogel stood before the perforated 25 millimeter plate, running his fingers over entry holes, feeling the sharp edges of exit wounds in steel, trying to reconcile what he was seeing with everything he thought he understood about ballistic performance. This wasn't possible according to German engineering assumptions. Yet here was physical proof that impossible had occurred. "Extend the range," Vogel ordered. 600 meters, same target thickness. The test team repositioned targets. Becker adjusted the Browning's sights. The morning had grown warmer, but Vogel felt cold as he considered implications of what they were discovering. If American ammunition could penetrate this effectively at 600 meters, it meant German armored vehicles were vulnerable to aircraft that should have posed no threat. 5 more rounds fired across 600 meters of range. The projectiles took noticeably longer to reach the target, visible as brief silver flashes in the morning light. The team waited for the range to be declared safe, then moved forward to examine results. 2 complete penetrations through 25 millimeters at 600 meters, 3 deep partial penetrations, each exceeding 15 millimeters depth. This was anti-tank rifle performance from a weapon designed primarily for aircraft defense. The Americans had created ammunition that redefined capability categories. 1,000 meters, Vogel said quietly. "We need to know the maximum effective range." The 1,000-meter test would be definitive. At such distances, projectile velocity would have dropped substantially. If penetrations still occurred, it would prove that American heavy machine guns remained lethal against armored targets at ranges where German weapons would be completely ineffective. The target was positioned. Becker made careful adjustments for bullet drop, calculating holdover based on preliminary ballistic data. The Browning fired its distinctive heavy cadence, sending 5 projectiles across 1,000 meters of range. The walk to the target took several minutes. Vogel used the time to mentally prepare his preliminary report. This wasn't going to be a routine evaluation documenting expected performance parameters. This was going to be a warning that would reach the highest levels of Wehrmacht command. The Americans had fielded a weapon system that fundamentally altered tactical calculations. The 1,000-meter target showed 3 penetrations completely through 25 millimeters of steel. At a distance where German pilots considered themselves reasonably safe from bomber defensive fire, American guns were punching holes through armor that protected German ground vehicles. Vogel's team spent the rest of that day conducting additional tests. They fired at angled targets to simulate armor slopes. They tested penetration against face-hardened steel, matching German vehicle armor specifications. They fired at aluminum plates matching aircraft construction. They tested incendiary effectiveness by backing steel plates with fuel-soaked cloth to simulate aircraft fuel tanks. Every test confirmed and expanded their initial findings. The armor-piercing incendiary ammunition penetrated face-hardened steel almost as effectively as homogeneous plate. Angled armor helped, but not enough to provide meaningful protection at ranges under 500 meters. The incendiary compound ignited reliably, setting fires in simulated fuel tanks with disturbing consistency. The tracer rounds proved nearly as deadly as dedicated, armor-piercing ammunition capable of penetrating 15 millimeters at combat ranges. Even the standard ball ammunition, intended simply as bulk loading between specialized rounds, could penetrate 8 millimeters at substantial distances. The Americans hadn't just created one effective ammunition type. They'd created an entire family of lethal projectiles. As evening approached and testing concluded for the day, Vogel began drafting his preliminary assessment. The document would be classified immediately upon completion, its contents restricted to officers with specific need to know clearance. What he had to report would alarm commanders throughout the Wehrmacht and Luftwaffe. The American 50 caliber Browning machine gun, when loaded with armor-piercing incendiary ammunition, represented anti-armor capability equivalent to dedicated anti-tank rifles at ranges exceeding 1,000 meters. The weapon could defeat 25 millimeters of armor plate under conditions that represented realistic combat engagement parameters. More significantly, American bombers carried these weapons in substantial numbers. A B-17 with 13 50 caliber guns represented a flying fortress in literal terms, capable of engaging ground targets with devastating effectiveness while simultaneously defending against fighter attacks. German armored vehicles that approached bomber formations during forced landings or low-altitude operations would face fire equivalent to encountering multiple anti-tank rifle positions. The penetration performance also explained mounting Luftwaffe losses. German fighter armor, typically 8 to 15 millimeters thick, offered virtually no protection against American defensive fire at typical engagement ranges. Luftwaffe pilots closing to 400 or 500 meters to use their cannon effectively were exposing themselves to weapons that could penetrate their armor protection as if it didn't exist. Vogel's report would note that German fighter doctrine needed immediate revision. The standing instruction to close within 300 meters before opening fire was suicidal against American bombers. Pilots needed to engage from maximum range, accepting reduced accuracy in exchange for staying outside the lethal envelope of 50 caliber defensive fire. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The implications for ground forces were equally serious. German doctrine assumed that light armored vehicles, those with protection between 15 and 30 millimeters, were safe from air attack, except from dedicated ground attack aircraft using cannon or bombs. The American .50 caliber changed that calculation entirely. Now, any aircraft mounting these weapons could engage light armor effectively. Over the following days, Vogel's team conducted expanded testing. They evaluated sustained fire characteristics, determining that the Browning could maintain prolonged fire without significant accuracy degradation. They tested different barrel lengths, discovering that even the shorter aircraft-mounted versions retained formidable penetration capability. They examined ammunition manufacture quality, finding consistency that explained reliable performance. One test particularly alarmed German observers. They positioned a captured French Saumur S-35 tank with side armor of 40 mm at 600 meters. While .50 caliber ammunition couldn't penetrate the main armor, it consistently defeated vision ports, optical sights, and auxiliary armor sections. Even against targets the ammunition couldn't fully penetrate. It inflicted mission-killing damage that would disable vehicles in combat. The ammunition's incendiary characteristics proved especially concerning. Testing against mock-ups of German vehicle fuel systems showed that even partial penetrations could ignite fires. The incendiary compound remained active through armor penetration, reliably igniting flammable materials on the far side of perforated plates. German vehicles hit by this ammunition would face not just structural damage but catastrophic fires. Sergeant Becker, examining expended projectiles recovered from backstop materials, provided additional disturbing observations. These projectiles retain structural integrity through impact, he explained, showing Vogel a recovered penetrator core. German 13mm projectiles often fragment when hitting hard targets. These American penetrators stay together, maintaining effectiveness even after punching through steel. The metallurgical analysis revealed sophisticated ammunition construction. The penetrator cores used properly hardened steel with consistent quality across production lots. The incendiary compound was stable in storage but reliably ignited upon impact. The cartridge cases showed excellent quality control with consistent powder, charges that explained the ammunition's reliable performance. Continuing Part 2. By the end of March 1943, Vogel had compiled enough data to produce a comprehensive technical assessment. The document ran to 47 pages, including detailed ballistic tables, penetration charts, and photographic evidence of test results. The conclusions were stark and unambiguous. American .50 caliber ammunition represented a quantum leap in heavy machine gun capability. The report made its way through Wehrmacht bureaucracy with unusual speed. Copies reached the Luftwaffe High Command, the Army Weapons Office, and eventually the Reich Ministry of Armaments. Within weeks, responses began flowing back to Kummersdorf, and those responses revealed how deeply the American weapons capabilities had shaken German confidence. General Adolf Galland, the Luftwaffe's fighter commander, requested immediate tactical guidance. His pilots were suffering mounting casualties attacking American bomber formations. If their armor protection was essentially worthless against .50 caliber defensive fire, existing attack doctrine needed complete revision. The standard approach, closing to 300 meters before opening fire to ensure hits with limited ammunition, was sending pilots into a lethal fire zone where American guns could shred aircraft protection with ease. Vogel's response recommended that fighters engage from 600 to 800 meters, accepting reduced hit probability in exchange for staying outside the .50 caliber's most lethal range. Even at those distances, American fire remained dangerous, but armor might provide some protection. The recommendation effectively admitted that German fighters couldn't safely close with American bombers, a devastating acknowledgement of American defensive superiority. The Army response focused on ground force implications. If American aircraft could engage light armored vehicles effectively with standard defensive armament, it changed fundamental assumptions about air-ground combat. German doctrine had assumed that armoured vehicles were reasonably safe from air attack, except when enemy aircraft made deliberate strafing runs with cannon or delivered bombs. Now, any American bomber overflying German positions represented an anti-armor threat. Field commanders received updated guidance. Light armored vehicles should avoid areas within 2,000 meters of downed or damaged American bombers, as defensive guns remained operational and lethal even after aircraft were disabled. German forces recovering downed aircraft should approach with extreme caution, treating each bomber as a fortified position with multiple anti-tank weapons. Personnel should use smoke screens and approach from angles that minimized exposure to defensive gun positions. The guidance represented a remarkable admission. Single damaged aircraft were being classified as significant threats requiring special tactical procedures. The American .50 caliber had achieved what German propaganda claimed for their own weapons: genuine force multiplication that altered battlefield calculations. Meanwhile, German intelligence intensified efforts to understand American ammunition production. If the .50 caliber's performance came from sophisticated manufacturing processes Germany couldn't replicate, it represented a technological gap that would persist throughout the war. If Americans were using secret alloys or advanced metallurgy, Germany needed to discover and counter those advantages. The intelligence reports that came back over subsequent months painted a disturbing picture. American .50 caliber ammunition wasn't produced using exotic processes or secret materials. It was manufactured in vast quantities using straightforward industrial methods at factories across the United States. The Western Cartridge Company, Winchester, and other commercial ammunition manufacturers were producing millions of rounds monthly, with consistent quality. This was almost worse than discovering secret technology. Secret processes could be stolen or replicated. But the Americans had achieved superior performance through basic engineering executed with industrial precision. They'd designed ammunition that could be mass-produced to exacting standards, creating consistent lethality across millions of rounds. German industry, increasingly disrupted by strategic bombing and resource shortages, couldn't match such production quality. Colonel Friedrich Halder, reviewing intelligence summaries at the Army Weapons Office, made a comment that captured German frustration. "The Americans don't innovate with exotic designs," he observed to his staff. "They perfect conventional approaches through industrial might. Their .50 caliber isn't revolutionary technology. It's evolutionary engineering supported by manufacturing capacity we cannot compete with." The observation highlighted a fundamental challenge facing German weapons development. German engineers could design sophisticated weapons that matched or exceeded American performance in laboratory conditions. But translating laboratory success into field-deployed weapons that soldiers could use effectively required industrial capacity, quality control, and production consistency that Germany increasingly lacked. German attempts to develop comparable ammunition revealed the depth of American advantages. The Wehrmacht experimented with improved 13mm armor-piercing rounds, trying to match .50 caliber penetration through enhanced projectile design. The results were disappointing. Even with optimized penetrator cores and improved propellant, German 13mm ammunition couldn't approach American .50 caliber performance. The fundamental problem was physics. The American cartridge was simply larger, containing more propellant behind a heavier projectile. German 13mm rounds couldn't overcome the energy deficit without completely redesigning weapons and ammunition systems, a massive undertaking that would divert resources from other programs. Some officials proposed developing a German equivalent to the .50 caliber, creating a new heavy machine gun chambered for a cartridge matching American dimensions. The proposal went nowhere. Germany was struggling to produce existing weapons in adequate quantities. Adding a new caliber requiring different manufacturing tooling, different supply chains, and different training programs was impossible given industrial constraints. Instead, German forces had to adapt to fighting an enemy with clear superiority in heavy machine gun technology. Luftwaffe pilots developed new tactics, accepting that they couldn't safely close with American bomber formations. Army commanders learned to respect American aircraft firepower, treating bombers as serious ground threats even when damaged or disabled. Naval forces, operating in bomber range, received guidance on the 50 caliber's anti-boat capabilities after several incidents where American aircraft strafed German coastal vessels with devastating effectiveness. The captured Browning at Kummersdorf became a teaching tool. Officers attended demonstrations where the weapon's capabilities were displayed against various target types. The goal was ensuring that commanders throughout the Wehrmacht understood what their troops faced when engaging Americans. Illusions about German technological superiority needed to be dispelled before they cost lives through tactical overconfidence. One demonstration in June 1943 particularly impressed attendees. Vogel's team had constructed a mock-up of a German SDKFZ 251 half-track using armor plate matching production specifications. The Browning engaged the mock-up from 800 meters, typical range for air-to-ground engagement. Within seconds, the 50 caliber fire perforated the vehicle's side armor, destroyed vision ports, and ignited simulated fuel supplies. Lieutenant Colonel Werner Schultz, attending from the Panzer Troops Training Command, watched the demonstration with visible dismay. "We've been teaching our crews that half-tracks provide protection from small arms and light weapons," he said to Vogel afterward. "You're telling me that American aircraft can shred these vehicles from altitudes where our crews won't even know they're being engaged?" "That's precisely what I'm telling you," Vogel replied. "The 50 caliber has effective range against light armor exceeding 1,000 meters. Your half-tracks are vulnerable to any American aircraft that chooses to engage them. Crews need to understand that when American bombers are overhead, they're facing anti-tank weapons, not just machine guns." The implications spread beyond tactical considerations. German intelligence realized that American ammunition production capacity represented strategic advantage as important as numerical superiority in aircraft or tanks. If the Americans could produce millions of rounds of highly effective ammunition monthly while maintaining consistent quality, it meant their forces would never face the ammunition shortages that increasingly plagued German units. By mid-1943, German forces on all fronts were reporting encounters with American 50 caliber fire. In North Africa, before the Axis collapse, German Afrika Korps units documented attacks by American P-51 fighters and B-25 bombers using 50 caliber guns against vehicle columns. The reports described devastating effectiveness, with light vehicles destroyed and heavier armor damaged by aircraft that German doctrine hadn't classified as serious anti-armor threats. In Italy, after the Allied invasion, German units reported that American aircraft regularly engaged armored vehicles with machine gun fire. Half-tracks, armored cars, and even light tanks were being damaged or destroyed by strafing attacks using 50 caliber guns. German commanders complained that they couldn't move vehicles during daylight without facing anti-armor fire from aircraft that should have been threats only to unarmored targets. On the Eastern Front, where American-supplied aircraft were beginning to appear in Soviet service, German forces encountered 50 caliber ammunition used by Russian air units. The reports confirmed what testing had shown. The ammunition performed identically regardless of who fired it, and Soviet pilots quickly learned to exploit its anti-armor capabilities. The strategic bombing campaign over Germany brought the 50 caliber's capabilities home most directly. As American daylight bombing raids intensified through 1943 and into 1944, Luftwaffe losses mounted. German fighter pilots reported that American defensive fire was far more lethal than expected. Aircraft were being damaged at ranges where German doctrine said they should be relatively safe. Armor protection that should have stopped. Machine gun fire was being penetrated consistently. General Gallen's fighter forces developed increasingly desperate tactics. Some units experimented with approaching from directly ahead or behind, minimizing exposure to broadside defensive fire. Others tried vertical attacks from above or below, though American bombers' defensive coverage proved effective even against these approaches. Still others advocated standing off and using rockets or cannon fire from extreme range, though accuracy at such distances was poor. None of these tactics fully solved the problem. American formations with their massed 50 caliber defensive firepower created kill zones that German fighters entered at their peril. The bombers couldn't be left unmolested, but attacking them cost casualties that Luftwaffe fighter forces, already outnumbered and facing fuel shortages, increasingly couldn't afford. Post-mission intelligence interviews with captured American aircrew revealed another disturbing fact. The 50 caliber ammunition was so reliable that American gunners developed tremendous confidence in their weapons. They would engage German fighters at ranges exceeding 1,000 meters, firing long bursts, knowing that even at extreme distances, hits could inflict serious damage. German pilots reported seeing tracer streams reaching out to seemingly impossible distances, with strikes still occurring. The psychological impact on Luftwaffe morale was significant. Pilots who'd been trained to believe in German technological superiority discovered that American machine guns outperformed comparable German weapons by wide margins. The revelation that even their armor protection was largely worthless against American fire contributed to growing sense that the Luftwaffe was fighting a losing battle against enemies with material superiority. German propaganda tried to counter declining morale by emphasizing quality over quantity, claiming that German weapons remained superior despite American numbers. But pilots who'd faced American 50 caliber fire knew better. The Americans didn't just have more weapons. They had better weapons, produced with quality that German industry increasingly couldn't match. By 1944, German industry attempted minor improvements to existing weapons, trying to narrow the performance gap. Enhanced 13mm ammunition with improved penetrator cores entered production, offering modestly better armor penetration. But the improvements were incremental, and they came too late to affect the war's trajectory. American 50 caliber ammunition continued to outperform German equivalents by substantial margins. The captured Browning at Kummersdorf continued service as a testing benchmark. When German engineers developed new armor configurations, they tested them against 50 caliber fire to ensure adequate protection. When new aircraft designs were proposed, armor schemes were evaluated against American ammunition performance. The Dupper, weapon that had been captured as intelligence curiosity, became the standard against which German defensive measures were judged. Vogel, promoted to lieutenant colonel by late 1944, reflected on his findings in a private journal entry discovered after the war. "We tested the American 50 caliber, expecting to confirm our superiority," he wrote. "Instead, we discovered that in this critical weapon category, we are categorically inferior. The Americans have created ammunition that redefines heavy machine gun capability. We cannot match their performance with existing weapons, and we lack resources to develop equivalents." The admission was remarkable, coming from a German ordnance officer trained to believe in German engineering excellence, but the evidence was undeniable. The Americans had fielded a weapons system that German industry couldn't compete with, and that weapons proliferation across American forces represented advantage that manifested in countless tactical situations. The 50 caliber's anti-armor capability found applications beyond aircraft defense. American forces mounted Browning guns on vehicles, creating mobile fire support platforms that could engage light armor effectively. They positioned them in defensive positions where they provided anti-vehicle coverage in addition to anti-personnel fire. They used them in coastal defense roles, where the ammunition's ability to penetrate small boat armor proved valuable. German forces facing American ground units learned to respect positions fortified with 50 caliber guns. These weren't merely suppressive fire weapons. They were genuine anti-armor threats capable of destroying light vehicles and damaging heavier armor. German attacks that might have succeeded against positions armed with conventional machine guns failed when encountering 50 caliber defensive fire. The ammunition's incendiary characteristics added another dimension to its effectiveness. German vehicles hit by 50 caliber fire didn't just suffer structural damage. They caught fire with alarming frequency. Fuel systems, ammunition storage, and hydraulic systems all proved vulnerable to incendiary rounds that ignited on impact. Crews who might have survived armor penetration were killed when their vehicles burned. German tankers interviewed after the war consistently cited .50 caliber fire as among their most feared threats. One Panzer IV commander stated, "We could engage enemy tanks in gunfights with reasonable confidence. But American .50 caliber positions were different. They could hit us from distances where we couldn't effectively return fire, and their incendiary ammunition meant hits often caused fires. We learned to avoid American machine gun positions whenever possible." The statement captured how thoroughly American ammunition had changed tactical calculations. German armor, supposedly the elite of Wehrmacht forces, was avoiding machine gun positions because those positions threatened them with weapons that should have been ineffective against armored vehicles. By war's end, German ordnance offices had compiled extensive documentation of American .50 caliber capabilities. The reports made clear that this weapon system represented one area where American technological and industrial advantages had created decisive military superiority. German forces had learned to respect and fear the .50 caliber, and that respect was based on hard experience of its lethality. The lessons influenced post-war military development across multiple nations. The .50 caliber Browning became the standard heavy machine gun for NATO forces, with many countries adopting it directly or developing weapons with similar performance. The ammunition's effectiveness validated the concept that properly designed heavy machine guns could serve anti-armor roles in addition to anti-personnel and anti-aircraft missions. Soviet forces, having experienced American .50 caliber ammunition through Lend-Lease equipment, developed their own heavy machine gun systems inspired by observed performance. The Soviet 14.5mm KPV heavy machine gun, entering service shortly after the war, reflected lessons learned about the value of powerful heavy machine gun ammunition with anti-armor capability. German post-war weapons development, constrained initially by occupation restrictions, eventually resumed with doctrines shaped by wartime experience. When West Germany rearmed in the 1950s, their forces emphasized heavy machine gun capabilities, recognizing that modern conflicts required weapons that could engage both personnel and light armor effectively. The American .50 caliber's legacy extended beyond immediate military applications. The ammunition demonstrated that relatively simple weapons, when engineered properly and manufactured with industrial precision, could achieve performance that sophisticated designs couldn't match without equivalent production quality. The lesson influenced American defense procurement for decades, emphasizing reliability and manufacturability alongside raw performance. The testing at Kummersdorf in March 1943 had revealed a truth that German leadership struggled to accept. American industrial might wasn't just producing more weapons than Germany. It was producing better weapons, manufactured to standards German industry couldn't match. The .50 caliber Browning and its ammunition represented that superiority in microcosm. Major Vogel's original assessment, that the American ammunition represented anti-tank rifle performance from an aircraft defensive weapon, had proven conservative, if anything. The .50 caliber exceeded anti-tank rifle capability in many parameters, offering superior penetration at extended ranges while maintaining rate of fire that anti-tank rifles couldn't match. The Americans had created something genuinely revolutionary wrapped in conventional appearance. The weapon's proliferation across American forces multiplied its impact. By 1944, every American bomber, many fighters, most ground vehicles, and countless defensive positions mounted .50 caliber weapons. German forces couldn't engage American units without encountering these guns, and encountering them meant facing weapons that could threaten everything from infantry to light armor. The psychological dimension of fighting against superior weapons cannot be underestimated. German soldiers and airmen knew, from experience and from their own intelligence services, that American .50 caliber weapons outperformed German equivalents. That knowledge affected morale, influenced tactical decisions, and contributed to growing sense that Germany faced enemies who held technological as well as numerical advantages. In the final analysis, the .50 caliber Browning and its ammunition represented exactly what German testing had revealed in March 1943. It was a weapon system that redefined capability categories, achieving anti-armor performance from a heavy machine gun that German doctrine had considered impossible. The Americans hadn't just improved existing technology, they had created something fundamentally more capable, and they had manufactured it in quantities that ensured every engagement involved facing these superior weapons. The story of German officers testing captured American .50 caliber ammunition isn't merely an account of ballistic testing. It's a case study in how technological and industrial advantages manifest in warfare. The Americans designed better ammunition, manufactured it to higher standards, produced it in overwhelming quantities, and deployed it so widely that German forces couldn't avoid encountering it. Each of those factors alone would have been significant. Combined, they created weapon system superiority that affected tactical and strategic outcomes. Major Vogel, standing in the cold observation bunker at Kummersdorf on that March morning in 1943, had witnessed the beginning of a revelation. The first rounds fired through that captured Browning had started a process of discovery that would fundamentally change German understanding of American military capability. What began as routine ballistic testing had become an intelligence coup that exposed German vulnerability and American strength in a critical weapons category. The penetrated steel plates, carefully preserved and documented, told a story that no amount of propaganda could obscure. American engineering, backed by industrial might that German couldn't match, had created ammunition that German armor couldn't reliably stop. The .50 caliber had pierced not just steel plates, but German confidence in their technological superiority. Years after the war, Vogel would reflect on that testing period as a turning point in his understanding of the conflict. "We entered the war believing German engineering would overcome Allied material advantages," he recalled in post-war interviews. The .50 caliber testing showed us that Americans possessed both material and technological advantages. We couldn't out-engineer them, and we couldn't outproduce them. The .50 caliber represented that reality in pure form. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.